Hello everyone, welcome to today's lesson on slopes. So in the last few lessons, we actually talked a little bit more about how to graph straight lines. Alright, so I said all you gotta do is find 3 points, plug it in, and then connect the lines. Alright, so here we got an even easier way to think about graphing lines. Right? So we can think about slopes when we graph lines using this form called the slope-intercept form. Right? So it will always be in this format where we have y that equals to a number, the m, in front of the x, adding on to another number behind it, which is the y-intercept. Right? So every slope-intercept form will be in this form. So for example, you can see something like this, right? Or something like this. We have a singular y with a number in front of the x and then a constant at the very back. Okay, and now this tells us two pieces of information that we need to graph a line. The first one is the y-intercept. So this constant here that's tagged along is the y-intercept. So this means that this is where this line touches the y-axis. And the second piece of information is the m, which is the slope. Now the slope, we call this the rise over run, or the change in the y over the change in the x. That's the difference of y over the difference of x. So let's take this first example here. All right, let's get our grid lines or axes out. Okay, so we got our axes here. The first piece of information is the easiest one, the y-intercept, because it's literally given to us, which is 0, -3. Right, so this tells us the y-intercept. In this case, it's -3. So this line touches the y-axis at 0, -3. Right, that's our y-intercept. Okay, next is the slope. Now the slope is just whatever number in front of x is. In this case, it's 3/4. Right? I'm just literally taking this number, the coefficient of x. Right, that's the slope. Now the slope is the rise over the run, the change in the y over the change in the x. So let's see. We got a 3 here, so we go up by 3. Right, because that's changing y, we go up by 3. And then we go to the right by 4. Right, that's our x. And that's it. That's our second point. And then the final step is to connect it with a line with a ruler. And that's literally it. Okay, that's it. That's how we draw a line, right? Just 2 steps. First step is we find the constant, that's our y-intercept, where this line touches the y-axis. Second step is look at the coefficient of the x, which is a slope. And this tells us how much y we're changing by. In this case, +3, so we're going up by 3. And how much x we're changing by, which is +4, so we're going to the right by 4. Okay, let's try another example. Okay, y-intercept. In this case, once again, very easy. Just find a constant. So 0, 4. So once again, we drop our, oops, that's very off. Drop our grid lines, 0, 4, right there. Okay, slope. We can see here the slope is -3. Right? And if we remember, whenever we just have a number by itself, we can always assume that this is just -3/1. Right? Because again, we're usually just too lazy to write out the over 1 part. But every single constant is technically the number over 1. Okay? So now what happens with a negative slope? Right? So make sure that only one of the values is negative. Right? It's either -3/1 or 3/-1. Personally, I like to treat the y value as the negative number. So with the slope, we are going down by 3. Right, -3. Going to the right by 1. That's our second point. And hence, This is our line. Okay, and then that's it. All right, so when we have a negative slope, we just have to make sure that only one of the values is negative. Because if both values are negative, then that's just positive, right? Because what we can also do is from this point, we can go instead of a negative y, we can go a positive 3, but a negative 1 to the left. Okay, so we got the exact same line. Okay, so again, up to you which one want to be negative, but only one of them is negative. Okay, so now how about going the other way around, right? How do we find a slope based on 2 points? Right? So remember, the slope of a line is the rise over run, which is the change in the y value over the change in the x value. So all we have to do is to subtract the y values and the x values, right? This is the y value. Oh, that's the y value of the first point, x value of the first point. We have the y value of the second point and x value of the second point. So all we do now is subtract the y's over subtracting the x's. So y minus y is 1 minus negative 3. And this over 2 minus negative 5. Which is just 4 over 7. And that's our slope between the 2 points. Okay, that's it. All right, so all we're doing here is subtracting the 2 y values of the 2 points and then dividing that over the 2 x values of the 2 points. And as you can imagine, it actually doesn't really matter which order you do it with. But you can even do the first y point minus the second y point. Right, and then negative 5 over minus 2. Right, so instead of this minus this, we're doing this minus this. And as you can see, right, it's the exact same number. Right, the negatives cancel out to be 4 over 7. As long as you're subtracting the y and the y, x and the x, then it's fine. Okay, so let's do some more exercises. The change in the y is 5 minus 2, or 2 minus 5. Change in the x is 4 minus 1. We got 3 over 3, which is just 1. That's our slope of 1. Okay, so just be careful here. If you're doing 5 minus 2, make sure you do 4 minus 1, right? We cannot do 5 minus 2 over 1 minus 4. Okay, so make sure it's one set minus the other set. Do not mix and match. Okay, let's do it the other way around this time. So instead of negative 1 minus 5, let's do 5 minus negative 1 over negative 3 minus 4. 6 over negative 7. Okay? You can write it as negative 6 over 7 as well. That's fine too. Yeah, that's our slope. And of course, now if we know the slope of something, we can easily find the equation of a line. Alright, so let's check out the slope here. We got 2 points here. So we're going to the right by 3 and going up by 1. Right, which means that our slope is rise over run, which is changing y over changing x, 1 over 3. The y-intercept, as you can see here, is at 1, or 0, 1. And we know our equation is y equals to mx plus b. Okay, so m is the slope, b is the y-intercept. So all we have to do is to plug the numbers in. So y equals to the slope, x plus intercept, which is just 1. Okay, just going backwards. Okay, let's try another one. Slope here, we're going to the right by 1, going up by 5. Both positive. Right, so slope is 5 over 1, which is just 5. Y-intercept, right here, it's a 0, negative 2. So plug it into the slope-intercept form. We got a slope, x, and then the y-intercept, which is negative 2. Right, that's it. One more, same idea. Oh, let's do slope first, why not? Now look here, this time we're going down by 4, right? So it's -4, going to the right by 3. And then the y-intercept, in this case, is at 2. So the slope-intercept form is the slope x plus the y-intercept. Okay, how about horizontal lines? Those ones are weird, right? Let's check line number A here. The y-intercept for line number A, right? Clearly is at 2. Or 0, 2. How about the slope? Right? The slope here is weird because technically it's 0, right? Or not technically, it is 0, right? Because if we just pick any point on this line, let's take this point here, right? The rise is 0. The change in the y here is always 0, no matter where it is on this line, right? It could be here, could be here, could be here. The change in the y is always 0. And it's the change in the x, in this case, is 3. But it doesn't really matter how much we change, right? Rise over run is just 0 divided by anything. So the slope is always going to be 0. Right, so if we plug it into our formula, this is just 0x plus 2. Right? Slope is 0, we plug that into the m, y-intercept is the 2. So our equation is just y equals to 2. Okay, that's our equation, right? Because this is literally just a line where we touch the y at the y value of 2. That's why this line is just y equals to 2. How about for B? There's no y-intercept. Right, it's a vertical line, does not touch the y-axis at all. And the slope. Okay, now this one is weird, right? Because similarly, okay, well, let's pick another point. Let's just pick this point here. Right, we know the rise is -3 in this example. How about the run? Right, the run is 0. There's no change in the x values. Right, it's literally just a straight line down. So it's going to be -3 over 0, which, as you can probably imagine, that's illegal, right? We cannot divide anything by 0. And no matter what the point is, because there's no change in the x, the slope is always 0. So, and because that's illegal, we call this undefined. Right, there's no equation for this. There's no slope for this. But there is an equation. Right, so similar to how for A, right, this is the line at y equals to 2. Where is this line at? We notice here this line spans the entirety of x is -2. Right, this is -1, this right here is -2. So for a vertical line, it's just x equals to -2, or wherever the number is. Okay, so that's how you can find the lines equations of the lines, like a straight line. Okay. And now, of course, we have to be careful of the numbers that we use, right? We cannot just blindly use any numbers we see on the graph. Right. Here's Yvonne's biking trip. What's the slope? Okay, so right away, right, we notice here that, oh, hey, what we have to do is just subtract the 2 points, right? The y values and x values. We notice here that the values are very specific, right? Right here, the x value is at 3, whereas the y value is at 72. So here's our first point. Here's our second point. X is at 2, y is at 48. Okay, so the slope here is 72 minus 48 over 3 minus 2. Okay, so be careful here. Right, whenever we pick the 2 points to find the slope of something, we also have to see what the values actually are. Because right here, we see that we go up by 4 and go to the right by 2, right? By 2 grid spaces. So of course the slope is just 4 over 2, which is 2. But we notice here that each space here isn't just going up by 1. Right? Each space here is actually going up by 6. And each space to the right is going up by 0.5. Right? So we can count the squares easily to find the slopes when we have something like this, right? We do not have any numbers, so we can assume that each grid is worth 1. But here, each grid is given different numbers. So we have to follow the numbers, or follow the guide here. Sorry, the legend, that's the word. Okay. We find a slope here, it's a calculation. Slope is 24. Okay, domain range. Love that question. So, what are x values? Notice here how there's no line here, right? So, here, there should be a dot here. I forgot to put it there, but because this is a speed and distance graph, we can always assume that there's a point where there's at 0 time at 0 distance. We got this dot here. X is 0, x is 1, x is 2, x is 3. We separate them by commas, right? Because they are not lines, they're separate dots. Range. Once again, dot here that is 0. Dot here, y is 24, y is 48, y is 72. Okay, just like that. Okay, so let's describe our trip. Where's the y-intercept? Alright. We know that she starts here. So the y value where it touches y is at 0. Right, which makes sense because at 0 time, you're at 0 distance. And the slope we know from earlier is 24, as calculated above. So our equation is 24x plus 0, which is the y-intercept, so we don't have to write it out. And we can actually double check this. So let's take this point here, right? If x is 2, what's y? Right? We can see here, if x is 2, y is just 24 times 2, which is 48. Okay, so that's our equation. Just a little double check. Okay, so now what does the slope actually tell us? Right, the slope here, the 24, what does it tell us? We know what's the slope. We did the y value, right? The y over the x value. And if we look at this particular graph, we can see here that the y values is the time. Oh, sorry, the y values is a distance. And x values is the time, which is kilometers over hour. That might look familiar to many of you, right? Because that's speed. Right? So in this example, finding the slope, which is the y value over the x value, is pretty much finding the distance over the time, which is just speed. Right? So which means that the slope of 24, right, is telling us that this whole time she was traveling at 24 kilometers per hour. And now, should we connect the dots? Actually, yes, we should. Right? Because time and distance are continuous. Right? We can have, say, like half a time, or half an hour, or half a kilometer, right? Every single value here, right, can be a decimal. That's why they're continuous, and we can actually connect the line here in this graph. Okay, but that's about it for today's lesson, right? For slopes, all we need is 2 pieces of information. The slope, right, which is calculated by finding the difference of the y and x values, right? And then the y-intercept, which touches the y-axis. And then we can just find an equation like so. Okay, so with that being said, good luck practicing.